My name is Jamie Rowe, and today I'm going to be talking about the Hardy-Weinberg equation, since it took me a minute to fully understand and grasp. A gene pool is every copy of every allele at all loci in every individual within a population. So, for example, for the population pictured here, the gene pool would just be all the alleles within the 3 tier. Now, the Hardy-Weinberg equation can be used to find the genetic variation of alleles within a gene pool at an equilibrium. In this case, the Hardy-Weinberg equilibrium. The Hardy-Weinberg equilibrium is a phenomenon that occurs when a population's allele frequencies remain constant over generations. For this to happen, a couple of requirements have to be met. First of all, there can be no mutations, there can be no natural selection, random mating must occur, there must be a large population, and there can be no gene flow. If all of these conditions are met, the gene pool is not modified and the allele frequencies stay constant, keeping the population in the Hardy-Weinberg equilibrium. So the Hardy-Weinberg equation is used to see if populations are in the Hardy-Weinberg equilibrium. The actual equation is p squared plus 2pq plus q squared equals 1, where p represents the frequency of the dominant allele in the population and q represents the frequency of the recessive allele in the population. So if p represents the frequency of the dominant allele in a population, that means that p squared represents the frequency of the dominant homozygous genotype in a population. And if q represents the frequency of the recessive allele, that means that q squared represents the frequency of the recessive homozygous genotype. So with that logic, that means that 2pq represents the frequency of the heterozygous genotype in a population. Now we get to the difficult part, the actual application of the equation. As an example, let's pretend that there's a population of fish whose scales are either blue, green, or yellow, with blue being the dominant homozygous, yellow being the recessive homozygous, and green being the heterozygous genotype. Let's say we know the total population is 50, and we know that there are 8 yellow fish. The first step we take in order to use the Hardy-Weinberg equation is to find the frequency of Q. To do this, we take the number of yellow fish and divide it by the total population. This would give us the frequency of the recessive homozygous genotype, which is 0.16. So to find the frequency of Q, we need to find the square root of this, which is 0.4. Now, because P and Q are frequencies, they have to add up to 1. So to find P, all you would have to do is subtract Q from 1. This gives us 0.6. Now, P squared is 0.36. This is the frequency of the dominant homozygous genotype. And the final value needed for the Hardy-Weinberg equation, 2pq, the heterozygous genotype, is 0.48. So if we want to check our calculations, we can add all of our calculated values up, and they should equal 1, which they do. And if our calculated values align with the actual observed values, that means that this population is in the Hardy-Weinberg equilibrium, which means that allele frequencies are remaining constant. Okay, and that's the lowdown on the Hardy-Weinberg equation, so I hope that helped you guys out.